In this video, we are going to explore two exception safety guarantees in C++, the no exception guarantee and the basic exception guarantee. Exception guarantees are essentially a contract between the C++ specification and the programmer. They define what your program is allowed to look like after an exception is thrown. The exception guarantees are listed from the strongest guarantee to the weakest one. So today we are covering the bottom part of the hierarchy, the basic and the no exception guarantees.
So, it says here that you're proficient in C++.
This is the weakest form of exception safety. It means that if an exception escapes the function, the program makes no promises about the state of your object and resources. So anything can happen. Resource may leak, invariants can be violated, objects may end up in an invalid and inconsistent state, data structure can be partially modified. One important thing to notice is that this guarantee has nothing to do with the no except keyword. No except means a function promises not to throw. The no exception guarantee means if something throws, the program doesn't guarantee recovery or consistency. Better make the point, let's create a class named buffer, and this buffer maintains a pointer to an array that is dynamically created, position variable that is indicating which element has been inserted, and then a size. The size is the size of the array, it's the full capacity of the array. We can create the insert method that allows to insert an integer into the array, and we can also provide checks to make sure that we don't store data beyond the maximum capacity of the array. We can create also the assignment operator. We first make sure that we are not referencing ourselves, that other is not referencing this, and then we can start to copy one by one the elements. And notice that before creating the new element, we need to delete the data because we are substituting the previous dynamically allocate method with the new one. So we are going to delete the data, we assign null pointer, and then we create a new data and copy. We delete the move assignment operator, the move constructor, and the destructor will be simply the deletion of the data contained in the memory. So it's going to be delete of the data pointer. We can have also a print method that is going to just be useful for debugging purposes to see what is the base address of the buffer, the position, and the size, and then print all the elements. So the main function is going to be quite straightforward. So we are going to just, for the sake of this experiment, create a buffer of 1000 element, buffer 2 with 2000 element, and then we insert a few elements on the first and the second one. So the main point is the assignment operator. So we are going to try to assign B1 to B2 and see what's happening. As you can see, like in the example, in the output of the execution, seems that everything is fine. So in principle, we will think, okay, this is good enough. This code is robust, but it's actually not the case. Imagine that there is no enough memory. So when we try to allocate new memory with new, we're going to receive a bad alloc exception. So what happens in this case? What's the state of the object? The object is not in a correct state anymore. And you can see here the result of the execution. So in this case, there is no exception guarantee. We are not giving any exception guarantee. Next is the basic exception guarantee. Under the basic guarantee, if an exception occurs, this is what can happen. No resources are leaked. All the objects involved remain in a valid and usable state. But this state might not be what you expected. It's valid but unspecified. This is the guarantee that most of the standard library containers provide in many operations. In this example, we start from what we wrote before and we just modify a couple of things. The first thing is that we modify the copy constructor, and the copy constructor will be very similar. The interesting part is in the copy assignment operator. As you can notice, here we are first creating a temp object, and then we are using a swap. So to do this, we need to create also a swap function that swaps all the various data member of our class. And the swap function is a no except function. So it means that, as we've seen in the previous video, it cannot throw. So if it throws, it terminates. So this is this idiom is called copy and swap idiom, and this is useful to provide basic exception guarantee. Let's see why. So the copy can either succeed or fail. So since we are copying, we are not changing the state of our internal variable. If the copy succeeds, we can proceed to the swap. The swap is no except, so it will not fail. What happens here is either we can transfer everything, you can copy to the temp object, or we cannot do it. Let's simulate this by placing a throw of a bad alloc inside our copy construct before the actual copy. By now executing the code, we can see that the problem that we saw before in the previous example, it's not present anymore because the object is copied correctly. So it can either be fully copied or not. So if the exception is true, the object remains at the previous state. This brings me at the end of this video. I hope that you found this information useful, and I'll see you in the next one.